We do have gill arches. If you look at you have this question. If you look at the fetus, actually, if you look at any fetus, these are the fetuses of, whoops, let me at least make it so you can see it. This says fish, salamander, tortoise, chick, hog, calf, rabbit, and human. And if you look at the top row, can you tell which is which? I sure can't. Second row, you begin to see some differentiation and some clarity. Salamander has external gills. But if you take those two out, these three kind of look similar, these look similar, and then finally you get down to a stage where you really see the differences. But to answer your question briefly, yes, we have gill arches. The thing that's interesting about them is that every now and then they'll get infected or they'll become a cyst, in which case your doctor has to, or some doctor somewhere,
Do we still have?
Take a look on the far right. See, we still have one which goes to our vocal cord and the thyroid. This one is the upper part of the vocal cord pulse, and arch 1 involves the middle ear, bones, and the blood supply and nerve supply of the face. Okay, I knew somebody wanted to know about that, and then I wanted to, okay. What? Okay. Whatever floats your boat. Good grief. Let's try rats. This is it's not worth it. Sorry. I was trying to decide what I would do today. And, I think I'm going to stop there for now. Okay. Plate tectonics. If anybody looks at a globe, it's fairly obvious that Africa kind of fits, or South America kind of looks like it fits under Africa's horn, or whatever part of Africa that is. And for as long as I know, people have tried to figure out how that works. Well, obviously, before 1492, nothing happened, because we didn't even know America existed. But after that, people saw that, gosh, if you kind of just mush everything together, South America fits in there nicely, and North America kind of curls over and, attaches to Europe, and Antarctica can fit, I can't remember where. The problem is, the solution was found when they started looking at glacial scrapings. So what they found was this. You had a specific question about gills. Specific questions. science@jwedge.com. Please send me your questions or call me. I don't mind being called, even just to have a chat or to figure out what's what. Since I am officially retired, the only thing you would do would be to interrupt whatever the heck I was doing at the time, and interruptions aren't always bad. Okay. What I was talking about was plate tectonics and continental drift. And you've got Alaska, America, Baja. As I said, I'm not an artist. And then over here we have Africa, which looks like it goes like this. Yeah, let's straighten that. Anyway, the way that it was nailed down happened in World War II. There was a man aboard ship in the Pacific, and they were taking, he would take soundings with radar. So he would go ping, 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 ping. And then when he was done, he was put on, after World War II, and he found weird things under the mountains and valleys and other strange things underneath the water, and he found that very interesting. Then he was assigned over here in the Atlantic to look at the look out for for submarines, and so he continued to use radar, and what he found was that I'm gonna stick England and Ireland and Europe, and Spain down here. I keep doing that. I don't know why. Spain's a square in there. So what he did was he went back and forth looking for U-boats, firing radar down. And the thing that he found interesting was you could find layers on the bottom of the ocean, and it appeared to him that there was a central place, and then there would be layers that came out from it. They might be different lengths. And he said, you know what? This is fascinating. The lengths of the bumps on the east side of the Mid-Atlantic Ridge are identical with the contour in the east and the western side of the continental, in the Atlantic mid-ridge. Not only that, somebody started looking at magnetic fields. We can measure very weak magnetic fields now. And he found out, lo and behold, that the magnetic fields match. And they switch about every 10,000 years. So this one's going to go up, that one's going to go up. This goes down, that one up, up, down, down. He looked at that and he thought, how could that be possible? I mentioned glaciers and we'll get back to that, I'm sorry. I wanted to do this one first. How is that possible? How is it possible that that this pattern would take place? Well, shortly thereafter, they discovered that the Mid-Atlantic Ridge, which I drew in green, really should be in red. That was my lame way of saying, it's hot. This is where lava comes out. This is where you hear of the black smokers and the things underneath the ground. And his hypothesis was that lava from under the Earth's shell that we live on comes out, and just by natural occurrence it spills on both sides because both sides are about the same height or depth. So that he felt that it made sense to have different kinds of ridges, sort of like tree rings. We did that tree ring dendrology experiment. He said that this is the same thing, and maybe this represents things spreading apart. And if you reverse it, kaboom, everything falls into place, and you have one large continent.